Something happened to the web in 2025 that almost nobody outside the standards world noticed. It didn't kill JavaScript. But it quietly ended a 30-year monopoly, the rule that a browser speaks exactly one language and nothing else. And the companies betting billions on the web already know. So is JavaScript actually about to die? No. And also, kind of yes. The language isn't going anywhere, the monopoly is. Because starting this year, you can write in C++, Rust, Go, or C#, and it runs inside the browser at near-native speed, not translated into JavaScript. Actually executed. Not a lab demo either. Open Figma right now. That impossibly smooth canvas is C++ compiled to WebAssembly, and it made their app load more than 3 times faster. Photoshop runs in a browser tab today. Full desktop-grade software, shipped as WebAssembly with nothing to install. So why did this get real specifically in 2025? Because the standard finally grew up. WebAssembly 3.0 shipped, and its headline feature has the most boring name in all of computing. Garbage collection. That one dull phrase is the whole plot, and it refused to stay inside the browser. WebAssembly walked out onto the server and started eating containers alive. Want to know real money is moving? Weeks ago, a giant of the global CDN world bought an entire serverless WebAssembly company outright. 2 fronts, 1 shift, the browser and the server. Let me walk you through exactly what broke, and exactly what replaced it. First, some fairness, because I genuinely like JavaScript. It won the web for real reasons. It's everywhere by default. It ships in every browser on Earth with 0 setup, and you can build almost anything with it. Nobody sane actually wants it gone. But JavaScript pays for that friendliness in speed. It's dynamically typed, garbage collected, and largely figured out while it runs. For a form or a dashboard, you never feel the cost. For a video editor, a game, or a 3D engine, you slam face first into a wall. Developers hit that wall early. Back in 2013, Figma had already written their editor in C++ and cross-compiled it into a weird stripped-down slice of JavaScript called wasm.js, basically tricking the engine into running it fast. It worked, but it was a hack. And that hack worked so well, the browser makers made it official. In 2017, all 4 major browsers shipped WebAssembly, a real compact bytecode running near the speed of native machine code. For the first time, the browser had a serious second language. But version 1 came with a hard limit. A WASM module got exactly one thing to work with: a single flat block of memory and raw numbers. Perfect for C++ and Rust, which manage their own memory by hand down to the byte. Miserable for nearly every other language. Java, C#, Kotlin, Go, they all lean on a garbage collector to clean up memory for you. To run them in WASM, you had to compile a whole garbage collector into the module itself. Megabytes of dead weight before your code did anything useful. And you might ask, why not just let the browser run native code directly? Because native code can read anything on your machine. WebAssembly runs in a locked sandbox that can only do what you allow. Safety was always the entire point. This is the exact wall 2025 knocked down. WebAssembly 3.0 is a genuinely huge release. 64-bit memory, multiple memories, native exceptions, tail calls, faster vector math. But one feature towers over the rest. Garbage collection built directly into WebAssembly itself. Now a module can simply borrow the browser's own collector instead of dragging its own along. That megabytes of overhead problem I just described? Gone. Basically overnight. And the languages came flooding in. In a single year, Java, Kotlin, Dart, Scala, even OCaml shipped real WebAssembly backends, every one of them wiring straight into that new built-in collector. Languages that could never realistically touch the browser suddenly could, and efficiently. The 64-bit upgrade matters just as much. Old WASM was capped at 4 GB of memory, enough to choke on a big enough Figma file or a large dataset. The new ceiling inside the browser is 16 GB, and out on a server, effectively unlimited. You've almost certainly used this without noticing. Whole game engines, Unity, Unreal, export straight to WebAssembly now, and heavy tools like CAD software run in a tab. Anything that used to demand a download can increasingly just be a link you click. So who's actually winning on the web right now? Honestly, Microsoft. Their Blazor framework lets you build entire front ends in C# with no JavaScript at all, and it already makes up roughly 42% of all the WebAssembly on the live web today. The rest is a fair fight still warming up. C++ through Emscripten sits around 10%. Rust is barely 1.5%. Go is a rounding error. Early days, no question, but every one of those doors is now standing wide open. And writing it isn't exotic at all. Take a normal Rust function, add one small annotation telling the compiler to target WASM, and build. Out drops a tiny module any web page can call as if it had been there the whole time. Now here's the part most people miss. Everything so far, Figma, Photoshop, Blazor, that wasn't even the main event. The browser was never the endgame. It was a training ground. The real prize is the server. And that's the part quietly replacing infrastructure most companies are still paying for. The key that unlocked it is WASI, the WebAssembly System Interface. It hands a WASM module a safe, sandboxed way to touch files, the network, and the clock. Everything a real program needs, with no browser wrapped around it. And in 2025, WASI 0.2 and the component model both stabilized. Think of the component model as USB-C for software. Different languages, different runtimes. They just plug into each other. A Go component snaps straight into a Rust component with no glue code between them. That put WebAssembly on a direct collision course with the container. A Docker container drags an entire operating system around with it and cold starts in hundreds of milliseconds. A WASM module is just your code, sealed inside a tiny sandbox. How much lighter are we talking? A WASM function can cold start in under a millisecond, over 100 times faster than a typical container, using a fraction of the memory. For serverless, that's not an improvement. That's a different category. And it's safe by default, which is the quiet superpower. A WASM module can do absolutely nothing, touch no file, open no socket, unless you explicitly hand it that permission. Exactly what you want when you're running a stranger's code at the edge. Even Docker itself saw this coming. Docker added first-class support for running WebAssembly containers, and Kubernetes can now schedule WASM workloads right beside your normal ones. The tools that defined the last decade are quietly making room for it, which is why the entire edge went all in. Cloudflare Workers, Fastly Compute, Fermyon, all running WebAssembly in production, spread across hundreds of data centers, executing right next to your users instead of an ocean away. And then the money spoke, loudly. In December 2025, Akamai, one of the biggest CDNs on the planet, bought Fermyon, the company building serverless WebAssembly, outright. And companies like Shopify are already swapping containers for WASM on their hottest, most performance-critical paths. Okay, now let me pour some cold water, because that title really is a little unfair. The raw adoption numbers are humble. WebAssembly shows up on only about 0.35% of all websites, and that figure has been basically flat for 2 straight years. But averages lie to you. Look at where it actually lives. On the top 1,000 sites, the ones with real traffic and real performance budgets, adoption climbs to around 2%. It wins exactly where the work is hardest and the stakes are highest. And I won't oversell it. WebAssembly still can't touch the page directly. It has to reach back through JavaScript just to change a single pixel. The debugging story is rougher. The tooling is younger. This is a bet on the trajectory, not a finished product you deploy blindly. Because JavaScript still boots every single one of those WASM apps, it still owns the DOM. Every button, every click, every pixel of the page runs through it. You literally cannot start WebAssembly without it. JavaScript is the host, and it isn't going anywhere. So what actually dies here? Not the language. A belief. The old assumption that the web only runs JavaScript, that serious software can't possibly live inside a tab, that every tiny server function needs a whole operating system bolted underneath it. The shape that replaces it is far simpler than the hype. JavaScript is the glue and the friendly face of the app. WebAssembly is the engine room where the heavy lifting quietly happens. They're partners now, not rivals fighting over a single throne. So should you actually care? If you build CRUD apps and call APIs all day, honestly, not yet, and that's completely fine. But if you write the hot loops, the tooling, the edge functions, the parts where raw speed is the product, the floor is genuinely shifting under you. Here's the real advice. Don't go rewrite anything. Just learn what compiles to WebAssembly, a little Rust, some Go, some C#, and keep one eye on that component model. That's where the next decade of the web is being quietly poured right now. JavaScript didn't lose. It graduated. For 30 years, it carried the entire web alone. Now, for the first time, it finally has help. The biggest change isn't that another language arrived, it's that the web stopped caring which language you use. If this reframed how you see your own stack, subscribe. This is where we take the hype apart and show the receipts underneath.